Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, today we will continue on chapter 4, which is on physical chemistry. Chapter 4 is on kinetic. Okay, right. So here are the content. First thing first, you're going to learn about rate of reaction and then rate law. Also order of the reaction and then factor affecting the rates of the reaction, and also Arrhenius equation, reaction mechanism, and also last but not least is about catalytic kinetics. And then we go with this one. Okay, first thing first, as we know, rate of reaction is depend on time. Okay, let's say we have higher rate normally is occur at shorter time of the reaction. If let's say we have lower rates indicate that we have longer time of the reaction. So in terms of this, we refer to how long the time is actually refer to the production of the product from the reactants. Okay, so when the reactant change into the products, so what happen is the first thing first, concentration of the reactant will be decreased. Okay, in order to perform the product, concentration of the reactant will be decreased, while concentration of the products will be increased with time. Okay, and then the rate reaction decrease with time because of the reactant decrease with time. Okay, because of the reactant decrease with time, right? And then we look at on next slide. What we're gonna see here is let's say we have A towards B, A of the reactants to produce the B of the product. So what you have here, rate is equal to final concentration minus initial concentration over the time. Right, so what you have here is, let's say, when you have final concentration minus the initial concentration, that is equal to differential of the concentration. The unit is mole per decimeter cubic over delta T. Okay, delta T of the differential of the time. Okay, then that will be giving units of mole decimeter per cubic over second, or we can simplify into molar per second. Then, okay, rate. How to write rate? Rate is written based on the reactant one side, while the other side is on the product. So let's say if you refer to A produce the B, what you have here, rate is equal to any reactant, because of the concentration is reduced to perform the product. So basically, concentration delta A of the reactant is minus. Okay, because of the concentration is reduced over delta T, and then whatever product that you have is going to have a positive sign. So we don't need to put a positive sign here because of the concentration of the product is increased. So delta B over delta T. Okay. Alright, delta concentration differential of the concentration A is negative because of the concentration of A is always negative. Okay, right. Okay, on this example, we're gonna see this C2H4 react with O3 produce C2H4O plus oxygen, where you are given time from 0 second to 60 second and concentration as follow for O3, ozone. Right, the question asks you to find rate of the reaction for O3 after 60 seconds, number 2 after 10 seconds, and number 3 between 50 seconds and 60 seconds. Okay, look at number 1 first. Number 1 after 60 seconds. After 60 seconds means that T initial is this one, T final will be 60 seconds. Okay, and your concentration will be this one, and to be compared with this one. Alright, so look at this one. Write the solution for this. Right, first, number 1, the rate over first 60 seconds of the reaction. So we write rate as the concentration of the reactant because we just compare on O3, ozone. Okay, so you can put differentiate of ozone over delta T. Okay, delta concentration of O3 over delta T. And don't forget the sign of minus because reactant is always minus. Okay, and then that would be minus O3 final minus O3 initial over T final over T initial. So all the data can be get from the table just now. Okay, so we have the data concentration at final at 60 second adalah is 1.10, 10 minus 5 minus 3.2 at the initial at 0 this is at 60 seconds, this is at 0 second, okay, where this is for concentration, over 60 minus 0. Okay, that will give you rate 3.510 minus 7 molar per second. Okay, you must always remember the unit concentration is molar unit, for time is second per second. Okay, right. And then for solution for next question, between starting 0 second to 10 second of average, okay, what you can write here, okay, what you can write here is you have to compare between 0 and 10 second. Again, rate is equal to delta concentration of ozone over delta T at 0 at final is 10 seconds, so 2.42 10 minus 5 minus 3.2 at initial. Okay, molar unit is molar over 10 minus 0 second. That will give you rate of this value. Okay, while for number 3, between 50 and 60, so meaning that that's only between 60 second and 60 second only. You must compare between 60 second, what is the concentration, between 50 second, what is the concentration. Rate is still similar, minus ozone, concentration of ozone over differentiate of time. Okay, that will give you this value. Okay, remember T is always 60 minus 50, final minus initial, concentration of also final minus initial. Okay, right, that will give you 1.310 minus 7 molar per second. Okay, now is differential rate of equation. Right. Okay, if you have this kind of equation, for example, for example, number of mole of A, B, C, and D. Okay, that is represent the number of moles for compound of A, B plus B produce C and D. Okay, how to write the rate equation? Okay, in order to write a rate equation, we write R, or rate here is equal to whatever reactant we have first, and only we simplify to the product that we have later on. So we start one by one. We start with A first. Okay, so it's equal to minus 1 over whatever mole of A that you have here. Let's say this is 2 mole. So basically this one over 1 over 2. Okay, 1 over 2. Okay, and then D, concentration of dt. You can put delta, or you can put sign of D. Okay, you can put also delta sign, or you can put simply dt. It's okay. So that is equal to minus 1 over A dA over dt is equal. It's always equal for rate equation. Equal to minus, again you have reactant of B. So 1 over B delta B over delta T, and that is equal to product. Product is positive. So 1 over C dC over dt is equal to 1 over D dt over dt. Okay, if you have more reactant here, or we have more product here, so you can add more here and more here at the back. Okay, alright. Okay, so minus sign it means that the concentration has been decreased from the reactant to produce more product at the ends. Okay, so example here, for example, we have nitrogen pentoxide 2 mole. Okay, produce 2 nitrogen dioxide and oxygen. Write the differential rate equation for the dissociation of N2O5. You must know when the question asks rate equation, that's what I show you just now is the way to write your rate equation. So you have to write rate is equal to minus 1 over 2. 1 over 2 is number of the 2 mole here. D and concentration of N2O5 over dt. Okay, that is equal to product, because we only have one reactant here, so that's only 1 minus here. Okay, and then simplify to the product immediately. Product is 1 over 4 for NO2. Okay, over dt is equal to D. If you have no mole here, just 1 over 1, or you don't have to write here, so you just write D, concentration of O2 over dt. Okay, right. So if the rate disappearance of N2O5 is 1.0 minus times by 10 power of 2 molar per second, what is the rate formation for NO2 gas under same condition? Alright, so you are given this one. you are given rate value for this one, and then you have to find what is the rate value for this. Okay, so you can put this this stoichiometry for to compare between this one and this one only. Okay, N2O5 and NO2. So what you can put reactant first, and then at the end is the product. So for reactant, 1 over 2 dN2O5 over dt, and then for the product 1 over 4, because we just compare the product of NO2, 1 over 4 dNO2 over dt. You don't need to include O2 because it's not being asked in the question. Right? So that will give you, you have to solve this one. Okay, you want to know, this is being given, so put in the bracket. So you want to know what is the value of concentration for NO2. So solve this equation. What you get is, yes, in the end you will get NO2. Alright. Okay, can go back. Okay, I can go back to the previous slide. Okay, that's okay. So that's, we give you the final answer just now. Okay, so now rate law. What is rate law means to you? Just now what we learned is about rate equation. Now we're gonna learn about rate law. Rate law is an experimental to determine equation which express the rate reaction as a function of concentration of the reactant. This is a bit different from rate equation. Because of rate equation, we have to compare between reactant and the product, but for rate law we have to write as full as this. Rate is equal to K, concentration of A and B. Okay, or if you have a C, you can put C here. K here is a rate constant. Okay, alright, so for this one, for example, how do we compare it? We compare it to this equation, A plus B is equal to C and D. For rate law, we just compare the reactant only. Okay, function of the concentration, because the meaning, the rate reaction as the function of the concentration of the reactant. So we just compare on whatever we have in the reactant. If we have G, E, F as the reactant, so you have to put here concentration of G, H, and so on. Okay, and F and so on. Right. So now rate K is equal to rate constant. So rate is equal to KAB again. If you want to find rate constant as the topic, so K, take it outside. K is equal to rate over concentration of A and B. Right. So rate constant normally is experimentally determined by the value. It's independent concentration but dependent on the temperature. If the temperature increase, rate constant also will be increased. If the temperature reduce, rate constant also will be reduced. The magnitude of K indicate the speed of the reaction. Small k, slow of the reaction. Large K, fast of the reaction.